Now that you had a chance to look at that short video of acid properties where we talk about them tasting sour, they can change colors of indicators, they produce hydrogen gas, let's take a look at some other properties of acids. Again, don't forget to read that section about the uses of these 5 common acids and their formula. Make sure you have that on your periodic table for any tests, because we are going to have quizzes on those Thursday and Tuesday. Now there's a 4-day weekend in between there where we're not going to have any instruction, so make sure that you've looked through that. Don't forget, use what resources you have available to you. So acids dissociate. Now dissociate means to separate in the presence of water. Notice I've given water the color of gray because it's neutral. The chloride in the hydrochloric acid that I have as an example here is also neutral. What makes this acid an acid is its ability to dissociate a hydrogen and add that to water and create this ion, H3O+. Now, this is called the hydronium ion. It's what makes an acid, at least at this level. There are other types of acids. We're not going to get into them, but they are later on a different slide. Notice all the charges are still balanced. This adds up to 0. This adds up to 0. +1 and a 1 minus also adds up to 0. Now, this is the definition of the Arrhenius acid. It's the simplest and first definition that chemists came up with, and it's the most narrowly defined. Now, throughout this whole unit, whenever we have H+, we could just as well have H3O+. These are more than equal. That's why I have 3 lines. The 3 lines represents defined as. So they are defined as the same thing. Strong acids dissociate 100%, and weak acids dissociate much less than that. Some around 5%, many of them around less than 1%. Do not get concentration confused with something that is strong or weak. You can have a weak acid that is very concentrated, and you can have a strong acid that is quite dilute. Even though those terms can get interchanged in common speaking, and I might flub up on some of these videos, it's important for you to realize that they have different meanings. Strong and weak are about how much they separate, and concentration is a measure of the moles per acid. For example, hydrochloric acid is a strong acid. It dissociates 100%. It can have a concentration maximum of a little bit over 12. Most of the time we work with 2 or 1. If we were going to be doing some titrations, we'd be making less than 1. When I made that solution of acid in that earlier video, it was a 0.15, which is fairly dilute, but it's still a strong acid. Here are the 3 definitions that we can work with for acids and bases. Svante Arrhenius was a scientist who came up with this definition, and he said that an acid is any compound that increases the H+, which is also H3O+, in a water solution. The base is anything that increases the OH, or hydroxide, solution. Bronsted-Lowry were 2 scientists who came up with a wider definition, because they noticed there are some things that don't just donate H's or produce hydrogen plus or hydroxide. And they define the acid as anything that is a proton donor. And remember, a proton is the same thing as a hydrogen ion. And bases are anything that are proton acceptors. Notice the H plus proton here would be accepted by a hydroxide and form water. That's what makes a base a base. This is the definition that we use most of the time. One of the definitions that we're not going to talk about, it will be discussed in Chem 1111 if you take that next year, are Lewis acid and bases. Now this is the same Lewis from Lewis structures. The definition goes beyond the scope of this class, but it's here just for your reference. So remember, acid properties being Bronsted-Lowry are proton donors. That's hydrogen structure. Here we have a hydrogen. Here we have this hydrogen. Here we have that hydrogen in those acids. Sometimes there are hydrogen in other formula that do not count as being acidic. Notice in acetic acid's case that those three hydrogen are combined with carbon. They will never be acidic hydrogens. It's almost always attached to an ion or an oxygen. Okay? So these are not acid hydrogen. Now some acids, like sulfuric, have more than one hydrogen that they can donate. We call those polyprotic, for poly meaning more than one. Specifically, phosphoric acid is triprotic because there are 3 hydrogen that it can donate, and sulfuric acid has 1 hydrogen that it can donate. Those are the only examples we're going to see in this class. We've seen this formula in reaction. Let's talk a little bit about bases. Bases are more, well, simple and basic. Again, I've put this in gray to indicate that it's neutral, and blue because that's the color of bases for hydroxide. Bases simply dissociate. If they dissociate 100%, then they're strong bases, and if they only dissociate less than that, then they're weak bases. But they are things that have a hydroxide in them that increases the hydroxide they have, which can then act as a proton acceptor. Some substances can act either as a base or an acid. Those are called amphoteric. Ampho meaning the Greek prefix for both, as in amphibians. You've seen these pictures before. Thank you for watching this video.